Okay, today's actually a very important lesson in the sense that it's something new, something you haven't seen before. And our goal is to write and evaluate rational exponents in more than one way. So we're talking about, in this case, rational exponents. And if you look back in your notes, when we talked about exponents, we talked about integer exponents. So now what we've done is replace the word integer with rational. So exactly what are we talking about when we're talking about rational exponents? Well, first of all, a rational number is a number that can be written as a over b, where b doesn't equal 0 and a and b are integers. So in other words, it's any number that can be written as a fraction. Now, because integers can be written as a fraction, you're going to find in this section, I'm not going to put the numbers like 1, 2, 4, even though they are also rationals. They are literally going to be fraction numbers. Now, there's an issue with that because if you recall when you first learned about exponents, exponents was defined as repeated multiplication. So 3 times 3 times 3 times 3, and they define that as 3 to the power of 4. So we take the base 3, we multiply by itself 4 times. Now the problem is, when I'm talking about rational exponents, is the following. How then can I define 9, the number 9, to the power of 1/2? When it was 3 to the power of 4, I multiplied 3 by itself 4 times. How do I do that with 9? Well, no, we don't take 9 and divide it by half. That's not how it works. So what it means by 9 to the 1/2 is we take that rational, the 1/2, we put it under a root sign. Now you're thinking, that's a square root sign. Yes, it is a square root sign, but sometimes the root is not a square root. Okay, so this case, actually 9 to the 1/2 actually is the second root of 9. The second root of 9. And you know what that equals, right? So let's take, for instance, what this means. And it's going to take a little bit for you to understand what they're talking about here. So it kind of implies, in a sense, that I'm taking the second root of 9, and I know the second root of 9, well, 9 I can write as 3 times 3. We all agree about that, right? Now, the answer here is 3. Now the reason it is 3 is because of this number 2 here. And I have a product of two identical numbers, 1, 2. And so that means the square root, or the second root of 9, is the number 3. Now what happens when we get to other numbers, however, it plays out a little bit differently. So take, for instance, 16 to the 1/4. Well, that I can write very similar to what I did with the square root of 9, and it can be written as the fourth root of 16. So again, I'm using the root sign. Now the root sign is not necessarily square root. Okay, here it's the fourth root. What that means, very similar to when it was the 9, is the fourth root, and I want to come up with a product for 16 that has the same number 4 times. Now I can think of 4 times 4, but according to this, I need 4 identical numbers. Well, I also know I could rewrite the 4 times 4 as 2 times 2 times 2 times 2, right? Because if I multiply these 2's together, I get the number 16. So the answer to the 16 to the power of 1/4, or the fourth root of 16, equals the number 2. The reason being is I have 4 of them. 1, 2, 3, 4. Okay, now let's take a look at 8 to the 1/3. When I look at 8 to the 1/3, again, if I rewrite it with a root sign, it's going to be the third root of 8. And just like the other questions, I can take them and we can rewrite 8 as a product of numbers. And if I can come up with a product of 3 numbers, which I think I can, 2 times 2 is 4, times another 2 is 8. Okay, so I have the number 3 and I have 3 2's. So the cubed root of 8 is 2. Now you heard me use some special language here. This is called the third root. It's also called the cubed root. And if you look on your calculator, you might even have a button that has the 1/3 on it because it is a very common root sign. And the one where it was 16 to the 1/4, it actually is we call it the fourth root. Sorry, my pen just doesn't want to pay attention to what it's supposed to do. Fourth root. Okay, now when it was a 2, such as my example with the 9, that is called a square root. Now, because squared roots are used so often in everyday life, if you look at your calculator, its square root button doesn't have a 2 there. So if there isn't a 2 there, and isn't a 4 or a 3 or another number, then we just assume it's a square root. Now, how can I use my calculator to deal with these numbers? Well, first of all, you know that you have a power button and it'll be one of these three. It depends on your calculator. So if I wanted to calculate 16 to the 1/4, the way I would key it in to my calculator is I would go 16. I would use one of these power buttons, bracket 1 divided by 4, close the bracket. So you have to use brackets that your calculator understands it has to divide that. So in the sense when you're doing 1 divided by 4, you're actually changing that to a decimal for your calculator. Okay. Now, many of the numbers we're working with that are perfect cubes or perfect fourth roots, we should be able to do them without a calculator.